So it's great to have you guys here. Thanks for your time. I guess to get started, before I get some of my questions, maybe like you guys could help enlighten me about your backgrounds and why you're excited about AI and science.
Yeah, thanks for the invite. I feel like this is character assassination by putting me right here in front of lunch, but that's okay. No, I'm happy to be on this is a great view. I've always wanted to come up to the Institute, so it's exciting to be here. And a really great panel, actually, before this one. I hope we can live up to half that. So I am an academic. I'm a tenured professor at University of Rochester. I was also somebody who worked on large language models in chemistry and explainability and graph neural networks, these kind of topics. And I was a red teamer for GPT-4. So I've been like using LLMs for a while before the I think big change when they came out. And I knew that I needed to get to a place that had more scale. So I know like the FROs, I think, is a really interesting topic. And I met with Sam Rodriguez, who actually, his thesis chapter, I think, was one of the first sort of ideas about FROs. And he is good friends with Adam. And Sam came to me and pitched like this idea of a new way of doing science in a focused organization with the resources of like an industry lab. And I thought this would be a great opportunity for me to work on AI and science. And Sam is a very, he likes to do things audaciously. And so it wasn't going to be like AI for science or like make science better with AI. It's automating science with AI is our mission, which is good in some ways because like it's very catching and I think it's exciting. On the other hand, if we like maybe only automate whatever 10% of science, I think it's still a really great leap forward for the field. So that's sort of how I got here and that's what I'm working on right now.
Thank you.
My name is Geet Khosla. I flew in from Denmark for this, so thanks for the invite. Great to be here. We're a startup on a mission to essentially get like 1 billion new people interested in scientific insights from research papers. I came at this from a very non-scientific angle. I've been building startups for 15 years, and 8 years ago I decided to focus on deep tech and science tech from an advisor, investor, sort of the other side of the aisle, so to speak, and learned a lot. And 4 years ago, I had a venture studio specifically helping scientists build companies in Europe and India, and sort of met these amazing scientists. And I said, why isn't there a line outside your door for people just collaborating with you? And they're like, yeah, we're not from a big school. We're not from, XYZ. I said, well, so what's the purpose of what are you doing here? I want to write papers the rest of my life. I want to sort of create new knowledge. I'm like, how many people read your paper? 2 on average. I'm like, I'm sorry, 2 people read, that makes no sense. So I couldn't sort of let that idea go and started the Proem a year ago.
Amazing, awesome, thank you. And so I guess, Andrew, I know you guys have just released a new summarization tool, which is like pretty amazing in my opinion. I'm not going to quote this correctly, but I remember I think there was a social media post about how it's basically the equivalent of like a early career grad student or something. I guess my question is how do we move from an early career grad student to a true expert in the field? Are there like technical limitations or like what's the next steps? How do we get there?
Yeah, thank you. So this is a tool we call Paper QA, and I actually, the panel before this was making me think about the journals and scientific papers. And I think it's a very strange world we live in that like publications exist. I think it's like a strange idea that we have, a ledger of all scientific output for the last few hundred years, and it's all networked with citations, which is almost like daily active users or something, or yearly active users of papers. I think it's an incredible artifact. And I think back to large language models, one of the reasons that large language models are so incredible is that they're built around natural language. And natural language is like the biggest collaborative project of civilization, was we built language to represent every concept we want to communicate. And so articles are like our equivalent to language in science. It's like a summarization of all our knowledge. And so when we started Future House, we wanted to automate science. And I'm a very direct person. It's like, well, step 1 in writing a paper is the introduction. Okay, so we have to automate that. And so we went to try to build a way to operationalize scientific literature. And so we built an agent which does all of the tasks that you can do. Like it will go and look at do a Google Scholar search. It will see who cited a paper. It will download the paper. It will read each page in the paper just at a scale that a human can't keep up. And so back to your question is, I believe that there is a saturation point on working with literature. like, I don't think there's some really, I mean, maybe there's some person who's just way better at doing a web search and reading a paper than others. But I think we're going to reach a point where there's just like some level of human or superhuman ability to do literature research, and there is not some upper bound. And so I think that, yeah, I don't think we're going to have a lot of trouble on pushing the limit. I think practically we were able to get PhD students and postdocs to benchmark themselves against our system, and we were able to beat PhD students and postdocs in the field. But, you know, you can keep going as like, okay, we pay them $20 and we gave them unlimited time. Maybe we could have paid them $1,000, and then maybe the scores would go up. Maybe instead of PhD students, yeah, maybe we use PIs. Or maybe we find these like, experts at looking over literature. But I think at this point, we've reached the point where we can automate what a PhD student or a postdoc can do at a scale of like, 100 per minute. Like we could rewrite, all of Wikipedia every couple months. We could write like a contract. We can basically look at every single paper that's put on archive and tell you how it agrees or disagrees with existing literature. So I think we've hit the scale and the quality level where we can start using it. So I think personally, I don't think we're that interested in trying to push even higher on this. I think we've just hit the point where we can start using it. And so now we're using it. That's what's exciting right now.
I guess, Geet, specifically for Proem, how do you think AI can be used in terms of like scientific communication, helping to engage like the average layperson to be more scientifically literate?
Yeah, we're trying to sort of figure that out. We're experimenting in a variety of different ways. We want to definitely sort of, I think there's two ways, right? Or maybe more than two, but definitely two we see. You might have a question, or you might have a thing you're grappling with that you want to go talk to. We built a simple answer engine to sort of answer with, we have our own index, and we also work with Semantic Scholar and OpenAlex, who have very large indexes of preprints. And then we sort of try to give, a handful of papers and then extract the core insight and give you a very short answer. Why we give you a short answer is because we wanted you to dive deeper. We want follow-ups. We don't want to give you like a wall of text, which we could. We just wanted to dive deeper, and we have sources and references in each output. That's one experiment, similar to Paper.ai, which I think is awesome and significantly cooler in many ways. But I think what we want to try to do is to say, what other ways? So the other way is you bring your own context. We just launched an experiment a few days ago, which is news. We call news, Proem News, news.proem.ai. And you can just bring in a link of any article. We use Google Vision, and we sort of scrape it. And then we try to ground what is this article talking about in science, and then find papers that are talking about the same topic, so you can explore the context around it. Proem is context or intro. So yeah.
Amazing, super cool. So we're talking a little bit about like summarization and scientific writing. What are some of the other use cases of AI in science you all are excited about? I know at the Future House conference, there was like evolutionary scale, I believe is a company, so like designing proteins. Curious what you guys are excited about outside of summarization and writing.
Yeah, so we should have a preprint soon on archive, hopefully. About our larger efforts. So I think the literature search, we basically were able to go from idea to execution on this project of basically going from an idea about how to tackle literature search or summarization. And then we were able to build benchmarks, like this is how well humans do, this is the task. And we've tried to basically expand that model to a lot of other different tasks. And at Future House, we're like a crow-themed organization because crows like can talk like parrots can, but they also use tools. So maybe they're a little bit smarter than parrots. And so we have this idea of putting together, like building an environment to solve a specific research task, and then building an agent that can accomplish that research task. And we put these two together, and we call that like a crow. And we're working on things like molecular cloning. Like I need to design a bunch of DNA constructs to do a very high throughbut experiment. We have an agent which can work with DNA manipulation tools and design that for you. We have an agent that can do some like protein design tasks. We have an agent that can work on things like designing enzymes. We have ChemCrow, which is an older work before we had really solidified our thinking, but we still have this, which is basically designing small molecules in the context of drug discovery or other organic chemistry tasks. And it can be like an agent that you can ask it to do things like make me a molecule with a specific color, give me 5 ways to make this compound and order them by, complexity or time to reagents arrive or cost. So we're trying to sort of build a blueprint of how to automate arbitrary parts of science, and then we're trying to build these different crows so we can actually have many different parts of science automated. And then, of course, we want to make it open-ended, so we want to see what can be done with all these automated systems when you have a sort of larger outside agent driving, let's try this, let's try that, let's do a literature search to see if it's novel, let's do a literature search to see if this has been disproven or not. And we're trying to get to the state where we're actually getting, scientific discoveries output from these systems.
Very cool. So at ResearchHub, we've recently been focused around peer review, paying for peer review, having open data sets of pretty rigorous peer reviews where we're actually rating the quality of the peer review itself. I'm wondering if you all have any opinions on automated peer review and how that could work in the future.
Yeah. So I recently took a week off from Future House to focus on an independent project. Still related to Future House, but it was peer review because I wanted to sort of just focus deeply on this problem. And I think right now, where these systems like AI systems can be helpful is I think all the ancillary steps of peer review. So I would do things like, are there any duplicated figures in it? Go use our paper QA system to see if any of these claims are strongly contradicted in the literature. And if they are strongly contradicted in the literature, what's the weight of evidence? Is this paper just saying, okay, we disagree with literature and here's our results for it? Or are they just writing an introduction that nonsensically erases or disagrees with the previous work? And one of the topics I was really excited about was looking through a paper, finding all the ways that they characterize a citation, and then getting that paper, and then taking the full text of the paper and seeing the way they characterize the paper, is it consistent with the paper? And this is what I did last week, and it's a really cool system. I actually found some mistakes in my own papers where I had mischaracterized a source or had a citation that was went to the wrong reference. And so I think a tool like that could really make an automated peer review system be real, but it wouldn't be a value judgment or an assessment of the figures or the results. But what it could do is just give you a very high signal assessment of if something is scholarly. Do they place it in the context of the field? Do they cite correctly? Is there any obvious fraud? I don't know what to do with that system. I don't know if that system is helpful or complements human reviews, or if this is in place of human reviews, but I have been thinking a lot about it. But I think the way that people think about automated peer review is you put the paper in an LLM and you give it access to paper QA and you say is this a good quality paper? And I don't think haven't figured that out yet, but I think there's been some great work on systematic peer review and meta reviews and evidence-based medicine, like Cochrane reviews, where they have a rubric of what is a good paper, what are the biases. I think that's something that could be done in an automated way, but we haven't started down that journey. And but I'm looking forward to trying to look at automating that sort of step. But I think this ancillary stuff, looking at a bunch of different ways that we've never looked at papers before, is very interesting.
What we try to do is because our focus is to get a sort of audience that maybe hasn't read the paper or wants to read it faster. So we actually want to try to get a diverse set of people to ask questions to the paper, and because we'll load it we'll sort of answer it based on the paper. But what we also trying to do now is send the corresponding author hey, these are the metrics of the week. These are the questions that were asked of your paper, and we answered it in this way with the best model we have hands and what we can do. Do you want to come and change it or rebut it or sort of open it up a little bit more to a larger, more diverse community? And we're super inspired by what's happening around what you guys are doing as well.
Very cool. I read a paper that came out a couple of years ago where it's about prediction markets in social science, where if you have an automated summary of a paper with some summary statistics, the average person, their sense of the world, can actually predict more than 50% whether a paper will replicate or not. So pretty cool, being able to involve the average person to help to judge the quality of science. I guess in your guys' careers with Future House and Proem, what's next? What are you guys excited about over the next couple of years?
What are we excited about? So when we finished this paper QA project, we looked at some numbers, and I was saying, there's 26,000 human diseases. We could rewrite the Wikipedia article for all 26,000 every 3 weeks, considering all the recent papers that came out. There's 20,000 genes in the human genome. We actually did write Wikipedia articles for all the missing genes that don't have Wikipedia articles. We could check every paper that's put onto archive every month for contradictions or disagreement with literature. And so, I think I don't that's not what's next for Future House. Like, those are things that we aren't going to do. I'm just listing them because I think they're very exciting, and it's like just opening the door. So I think we've kind of got like a new direction that we can do AI for science, and I think it's very exciting. I mean, for us at Future House, we measure our organizational success against novel discoveries. Like, how much are we moving science forward? And so we are building, I think, I know some people call it like a factory or something, but we have a lab, a wet lab down in Dogpatch. You guys can all come by and take a look at it. And we are trying to sort of build this pipeline where you're using these kind of systems to do new directions of science. For example, we can do a meta-analysis looking at 10,000 articles in like 12 hours to basically build a data set which never existed before. Or maybe it doesn't have to be articles. We can go look at a bunch of databases and do data analysis at scale. We can do hypothesis generation at scale. And now we're building these hypotheses that we can go test in the lab. And so what's next for Future House is going to be hopefully a steady stream of new data sets, of new discoveries, of these sort of systems. And I hope that we can also, like, we do work with academics or other nonprofits to like give them access to things like paper QA or like our protein design tools or molecular cloning tools to see what people can do with them. But I think we as a nonprofit have the freedom to not have to like focus on growing this platform, on growing, customers. But I think we're still exploring how do we fulfill our mission. So if anybody has great ideas on how to use these tools, happy to chat about it. And also, ResearchHub is also very interesting to me. I didn't know that much about it, and after getting ready for this event, I think you guys are doing some really interesting ideas about how to like incentivize the system. And I'm interested to see if any of these tools can like be related to that. So it's really cool, and a lot of cool ideas in discussion this morning.
Yeah, I kind of vaguely remember Sam saying something about trying to like get to the point where there's one new discovery every day, and I kind of love the transition from AI models in a computer to actual wet lab research and coming up with like new ideas and pushing science forward. It's really impressive.
Yeah.
Yeah, it's super exciting. I think we are a startup, so we do need to sort of make this work. Our focus is predominantly on adding more nuance back to sort of discourse, and if we can sort of make it easier for you to just go from whatever social channel you're on to insight and understanding, if we could reduce the time internally, I have something called insights per second or insights per minute. If we can sort of reduce the time at which someone doesn't know much about a field or is interested in a field or is in an adjacent field, and we can quickly help them understand what's happening in this field, who are the people that are working on stuff, who should you be talking to, and then maybe make those connections. We call it sort of the science creator economy. How can we accelerate those touch points and make them go faster? Yeah.
Totally. And maybe having more like public engagement within the scientific literature can help move us from our current universe to a new universe where policy is actually based on science, so that could be cool.
Yeah, we hope so, yeah. That'd be great.
So I guess before we go to lunch, anyone have any questions for the panelists?
Hi, how are you? I'm wondering how you're thinking about getting people to be good at prompting in AI models, because I talked to my friend today. She's using ChatGPT to cook. I have these ingredients. What can I make? I'm like, oh, cool. That's an interesting application I hadn't heard of before. That's happening through like social discussion. I may not have thought of that in the like probability space of what's possible. So how are you thinking about enabling people to ask better questions and better prompting through AI? Because I think that really is the tool that makes it really work so well.
We're really trying to focus on experimenting on the UX layer a lot. So, like, of course, people know about prompting, asking questions. That's kind of well known at the moment, and of course, could be better. But we're trying to see like how much insight and how much intelligence can we pack into another UX form? What could it look like? What could that be? Is it a link? Is it something else? That's how we're thinking about it at the moment.
Maybe if I can follow up, I'm curious to see what you think is like. How do you see that enable people to get to the expert level faster, right? In a UI for a tool, it's keyboard shortcuts. That's what the expert uses is keyboard shortcuts. They're not pointing and clicking. How do you get people to be expert in AI tools faster?
I think there's like maybe two kinds of users. I'll tell you guys about one thing we built is called hasanyone.com. Yeah, so you guys can go to hasanyone.com and you put down like a a scientific project you want to do, and it will use our tool to go and see has anybody done it before. And this is like, I think, a very direct, clear use. People get it. And I think it's something that will make people have more success in science. Like, it could actually accelerate science by reducing, or helping people find relevant work faster. But I think that's an example of something where, like, we have all the intention clear and you know how to use the tool. But then for like something like a power user or something, we have like an internal version of Paper QA where you can change tons of configuration options, like how many papers it considers, like where does it look for sources, does it do analysis on the data, does it give you structured XML or structured JSON. But I think that's just like a different sort of end user, and it's kind of like today there's people who know how to program, and so they can just do things with Python that are just very quick and efficient, and there's some people that just don't know how to program, and so they can use the existing scripts or existing things that are out there. And I think that's what we're going to go with AI. There's people who are just like, that's part of what they want to be good at. Like, people who are technology people and they want to have an Android phone and customize stuff. People like me, I don't understand how phones work, so I'll just use an iPhone and everything just works nicely. I think that's the same thing for AI. It's going to be some kind of people that want to really mess with it, explore it, and I think you have to build an interface for them, and then you have to build something that's really focused and one intention or one goal. Michael Eisen, let's hear Michael's question.
I'm curious how you avoid homogenization. Like for me, like in science, right, if every graduate student had perfect information and perfect instruction, they would all do the same thing. And I'm like, how like, and maybe that's, I don't know whether that's good or bad, but like a lot of what happens and a lot of progress happens in the weird corners of stupidity where people do things, right? Like if, how do you temper this level between, obviously you want people to know everything that they could know and have it all be useful versus like getting, like, where does it come in to, where does the variation come in? Where does the individual kind of people do different things? If I typed in, has anybody done this, right? Like, the assumption is if someone's done it, I'm not going to do it. Whereas like quite often the answer is, yeah, they did it, but they did it stupidly or they did it wrong. Or like, I just trying to figure out how you navigate that world.
Yeah, I guess my philosophy would be to give people perfect information and then use things like incentives to change people's, journey or how they want to go through science. So I think it's an interesting idea that like maybe there's some chaos injected or diversity injected in science right now because people can't find things, but I don't know if that's like the ideal state. But I think it's interesting. I haven't thought about this before, but I mean, that's my short answer is I think you want to align the incentives to get a diversity of ideas rather than align the information to get a diversity of ideas.
I think from my perspective, it's one of our advisors. He spent 10 years working on narrative extraction. So he's like the conversation that two grad students have at a conference or by the coffee. Like, that's what the paper is about, and the rest is there's a lot of stuff around it. And I think what we're trying to do is like sort of aligned a little bit with what you said. Like, we want to bring diversity in as much as we can, and try to find a way to. If there's something we can all sort of agree on for the moment, for this week, for this month, we want to try to make that as clear as possible. But that doesn't mean that it stops there. It actually starts there, hopefully. Yeah.
Yeah. So related to the prior question, this has come up a few times actually. Is can AI or LLMs do original research, or are they really just summarizing? And I'm curious your take on that, because I guess like in a literal sense, these LLMs are just predicting the next word, but maybe that's what our brain is doing too. It's hard. So maybe if not, we have a way to get there with these AI agents. So do you think AI agents can do original research, and if today, and if not, how do we get there?
I would say one of the most unexpected things for us was we thought hypothesis generation would be the hardest part of all of these areas. And we have found very good hypothesis generation. In fact, Ed Boyden was one of the people quoted here on E11 Bio. We had a meeting with Ed Boyden. We were messing around with some of these hypothesis generation things, and he was very impressed with the ideas that are coming out of them. And Ed Boyden is, a preeminent MIT researcher on brain science. It's probably a fancy word, neuroscience or something. And so I think we've actually seen really good successes, really good ideas come out of it. I will say that a big part of this is like grounding it. Like, you can't ask it to come up with a cool new plasmid and just emit the nucleotides directly. You have to give it access to the tools. You have to give it access to internet search. You have to have it be grounded in papers and be able to check, has anybody done this before? What did they find? So I think actually the novelty and the creativity of these is not going to be a limiting factor. Now, with that said, I think that's domain specific. I think of biology, it's a very empirical driven field. So there is no such thing as like the best idea. You just got to try 20 ideas and one of them might stick. I think in other fields, like, I don't know, physics, particle physics, perhaps, maybe you don't want to just try 20 average ideas. Maybe you only want to be doing experiments on the best idea. And then there, I think there is a real big curve of like very intelligent people, and it may take a while for LMs to get there. But I think so far we haven't found any blocking or difficulties with coming up with creative, plausible hypotheses from these models.
I think I'll add, our focus is sort of similar to grounding it, right? I think because you can, I think the lab out of Japan put out an AI researcher, which was this paper that was kind of getting a lot of attention some months ago, which did actually a lot of those steps you just said. It sort of did that. You give $15, it writes a paper, and it sort of had some interesting errors it made, but it's kind of worth going there. I think the grounding part, I feel, is also super important, and that's what we're trying to focus on.
So I think that like we often think about, I'm curious about peer review as we were talking about LLMs and AI agents. And I think that we often talk about peer review through the lens of like de-risking a paper. Like you want to make sure it's actually right and things like that. But I think there's also an opportunity to think about it through the lens of like, you know, almost a service that you're providing the author to help them shape and refine their idea. I feel like the peer review step is a step where it's really high leverage and is actually a huge source of wasted effort in academia. Like if you're in biology and you're trying to publish in Nature, you know, you're at this point where like the reviewers could tell me to do literally anything and I will do it. Like they could tell me, sacrifice 10 lambs and I'm going to go do it, you know? And so as a result, it's often a huge source of wasted effort because the reviewer is like, oh, hey, have you considered doing this, like this, that, and the other? Like you'll publish in Nature if you do it. And the PI's got to tell their grad student, like, sorry, like we're going to have to delay your graduation by 1.5 years because like you're going to do those damn experiments, you know? And so I wonder if you've thought about review as a service to the reviewer to ensure that their advice is actually helpful to the author. Like they're not going to send them off on a random goose chase, or they're providing information that is going to be like meaningfully incorporated into the paper and not like a weird side tangent because you have your personal academic axe to grind. I'm just curious if you thought about like that side of the review process with these kinds of services.
Yeah, I think that's an interesting idea. I haven't thought about it. I would say that you're on to something there, is that I think peer review is maligned a lot. I think a lot of people here like make comments about peer review being bad or anything. I actually find peer review to be a majority quite helpful. And I think a lot of my papers have been improved by peer review. Maybe I'm in different journals, I don't know. But I think it's a good service. And so I think you're right. It's like if we were in a world where peer review was optional, or like you could pay for peer review before sending off to journals, I think depending on the service that it's an interesting idea. It might work. And I think people would pay. Like I would pay for this tool that I was describing that I built to like see if all my citations are valid and like if I made any mistakes, or there's any duplicated images. Like maybe as a PI, it's a good strategy to have image duplication software in all your papers, or as a university as a strategy. So I think there is a market for these things, and I agree with you. I don't know though how that fits into peer review as a paid service, or how that's connected to publication or anything, but definitely I think this is very valuable technology.
I think someone said it earlier, sort of burn it all, the journals. I think I know a lot of scientists. I've spoken to a lot of the different fields, and many of them are very unhappy with peer review. So they're sort of annoyed that they have to talk to a bunch of people. And I think you described it pretty well, right? To get into this prestigious journal, then it kind of just naturally perverse incentives are just like screwed up, right? So I think what we try to do is at least where we stand is like, why don't we just get a much more diverse audience to also give you some feedback? That might not replace peer review, but maybe there's, one of our users, a power user, is a truck driver in Lisbon. He loves to read papers, and I mean, like, he's probably read a lot of papers, and maybe he's not an expert, but he sort of could maybe add something that you hadn't thought about, right? I think it's about sort of bringing a diverse set of opinions, diverse set of ideas to the table, and if we can build a tool that helps people understand that better, that might be useful. Yeah.
I've got a question about accuracy or truth seeking for LLMs. How do you think about, when you serve up a piece of research, making sure that not only does the AI model not hallucinate, but also, giving reasonable feedback as to the kind of research that is surfacing? So, has anyone tried this, such as like a Theranos? And like, oh yeah, maybe they have, but here's some flaws in the way they may have gone about this. So just curious at a high level how you all think about the nature of tuning for accuracy and for truth seeking, especially as this becomes a more integrated tool that scientists use on a regular basis.
Yeah, you bring up a really good point. Is when we wrote Wikipedia articles with our system and compared it against human Wikipedia articles, actually our statements were cited and correct and consistent with the sources at a much higher level than human written Wikipedia articles. And it was like a pretty big gap. It was like 12 points or something. But what we don't have is these systems are not good at distinguishing the quality of a source. And in fact, this is becoming an issue because as everyone knows, the internet has this sort of death spiral right now where New England Journal of Medicine's open access articles are completely blocked as hard as possible by Cloudflare and bot protection, and many of the most prestigious journals require you to solve CAPTCHAs if you want to download more than one paper, an hour. And the lowest quality journals, though, have no such restrictions. And you see this thing is that if I get an open access paper, I can get it more easily from a lower tier journal. And then what happens is you go and build these systems and suddenly they're pulling in all these articles from terrible, journals. And these LLMs are very susceptible. And there's like a paper that very assertively claimed that this one herbal tea could cure cancer. And it was so strong and the p-value was, 10 to the minus 10. So the LLMs were fooled by this. So what we have right now is kind of a hack, is that what we do is we show the LLM the journal that it came from. We use the finished publication form as ranking of journals. And we also say the number of citations this article had. And so we try to give this sort of indirect signal of if this is a good article. But that's why I spent this last week working on this automated peer review system, is that I want to do is every time we have an article come to these systems, I want to then run the automated peer review on them just in time so that we can peer review things as they're accumulating in our AI systems. And so, but again, like I said, it's only checking indirect things like, are the citations reasonable? Are there duplicative figures? What does this comments on PubPeer say about this article? Or on ResearchHub, what do they say about this article? So I don't think I've solved that. And I agree with you. It's actually a big issue, is that as the number of, there's 6 million papers published per year, 6.7 million papers published per year. There's 250 million papers out there right now. So we're a very high percentage growth right now. And we're gonna have to deal with that for these automated systems. And especially those 6.8 million papers, they're all from low quality, not all, but the majority of the growth is in very low quality journals that are just, emitting as much possible citable artifacts to boost some PI's careers. And yeah, we're gonna have to solve that. I don't want to solve it, but I guess we do have to solve that.
I think everything you said, I totally agree with. I think we're sort of running into similar issues as well in different ways. I think what we're really trying to focus on is the models are getting better, but that doesn't mean that it's just a different beast. I think we're focusing on query extraction, and we're focusing a lot on trying to build an index from the ground up to support and the gaps in the holes, and I think we haven't figured it out. It's definitely a big issue, and I think we'll keep working on it. Thank you.
If we have a minute, I will add one follow-up to that last question. Is that I actually had a call the other day with somebody from a pharmaceutical company, and they wanted to purchase Paper QA because they thought it would help them do due diligence in an automated system, because they want to acquire a company and it's a tight timeline, and they need to review all of the documents that the company provides. And I think that kind of there are some very I think there's situations where there's a big profit or there's a big value to be captured by doing automated peer review or doing fraud detection at scale. And I think about I don't know, hedge fund reports, company acquisitions, checking a startup like this. What is it? Sava? What is it? Kesava Biosciences? The PI co-founder had 80 papers with fraudulent images in them, right? And if somebody had run a system over that as part of their due diligence process, they would have caught this. And they don't even need to have an automated system. They could just hire. There's these people. They work for very cheap. They mostly volunteers that look at papers for fraudulent images. So I think there is a market, and somebody could go out and capture some value on this. But again, it's I don't know. It's hard to get people excited about this topic in general. But I think there is more initiative or impetuous to work on that now.
One question I have, I think you're alluding to folks like Dr. Elizabeth Vick, who does the image manipulation. Is there any way, like, if you build these models and they're being used, by like journals or institutions in order to check for like image duplications, but they're trained off of Dr. Vick's work, can you credit her in some way?
So I will tell you that if I were a billionaire and I could use my money to do something, I would make a prize right now for detecting duplicated figures in papers, because it is such an issue. Like you saw, it set back Alzheimer's research by a decade, right? And there is actually no good open source tool. And there is lots of work on, people have taken the effort to take her like images and build training sets. And you could build a challenge. Like there's this stupid ARC AGI contest, right? Which is like random puzzles made by Francois, and they're fun. But this is a real problem, and it's not solved, and nobody's working on it, and there's no incentive on it. So if anybody wants to make a challenge, that is one that has no benchmark and no solution for it right now.
I know James Heathers recently said that he thought it was either like 1 out of 7 or 1 out of 9 scientific papers had like intentional fraud in it. So, I think it's pretty diluting.
I mean, I think you want to be careful of those numbers because, like I said, the majority of growth in papers the last few years has been in this sort of, I don't want to call them like bottom tier journals, but they're bottom tier journals.
Hi. I think there are a lot of people working on these tools, and I think the problem is it's within the journal ecosystem. Sorry to bring it back to that. And actually, a lot of large publishers are technology manufacturers, and they see the next game as being in exactly this direction. There's a lot of talk. The key word right now is integrity tools, right? How do you assess something on technical metrics? So I guess my question is how can you build these things but not have them add to the church of the journal? How can you keep it out of that in the bazaar that would help foster the evolution of these new models that I think a lot of people are looking for?
Yeah, my co-founder, his former company, built a lot of AI services for the largest journals, so we know that space pretty well. I think we're specifically positioned the way we are to try to tackle it in a different way. We're super early, so we'll see how we do it, but I think we're definitely trying to keep it more open. I think the prize is a great idea. It's definitely something worth exploring.
We have to worry about the opposite, that they're going to make agents that are just much better at faking all this stuff. Like, duplicated image is like 10-year-old problem, right? Like, the problem now is
Yeah, you're absolutely correct. I think we are lucky in biology that duplicate images are like a thing, right? Because other fields, like in chemistry, like people fake like their NMR, but that's like not, you can't trivially detect that. And people get pissy already with duplicated images. Could you imagine if you're like, oh, you guys, like your analysis was wrong. It was like, oh, it was an accident, or like, your NMR is like, this doesn't match the compound. It was like, oh, oops. But with image duplication, there's no reason except to fake results. So I think we've gotten off really lucky, especially because it's in high stakes fields like medicine. But you're right. That's like a quirk of the world that happened that way. And going forward, I think
we're lucky that people are just bad.
Yeah, we're lucky, right? But there was actually a paper that came out recently on material science fraud detection. And what they did is they found that they could basically look at the AFM images or the TEM images, and they could see the like manufacturer of the instrument based on like some markings on the image. Then they could go back and see if that's consistent with the description of the instrument used in the paper. And they were able to calculate like a number, like the fraud amount in material science. The number was like, I think it was like 18 or 20% or something like this. And so it is in fact true that the like fraud rate is quite high, but we just don't have such good tools in other domains. So I think we do have to build, we are trying to do this, and I think other people are going to work on this, is like a full reproduction of papers with AI. And no, people don't want to do it. It's pretty formulaic, and I think we could get AI systems to just reproduce the analysis. Maybe not maybe they can't do the gels, but like they could do a lot of the primary analysis, and that could be like another signal. But it's a really hard problem.
I also think I don't want to use the word bullying, but like if you ask questions to a paper and if the researcher comes and defends it, like if we could sort of actually take a lot of the crap away in the middle and be like, hey, this is all the different questions you might have as a layman or as someone who is an expert in the field, and say this seems wrong, or I'm doing it this way. But if there was a place where those dialogues could be had in a more open way, away from generative models or supported by generative models, I think that could also be useful. Yeah.
Really quick question. So from the perspective of kind of this whole peer review talk, is the lack of accessibility of reviews an issue per se in this context because most of them are happening behind closed doors and there's not access to that data? Or are the reviews moot and really it's the paper itself that's the most important piece of context there? And do you use the reviews in any way to like maybe reinforce some of the statements made in that paper?
Yeah, open peer reviews, I think, is a really cool topic. I think it really would be valuable because we don't really have a visible discourse of quality of papers available for AI and for people. So I think you're right, that would be something more valuable. I mean, you can see PubPeer is like a kind of a measure of this, and I think you guys have a comment system on ResearchHub as well. I don't know, like, I guess my observation is that it exists. It would be great to like automate this process or at least like be able to measure it and see what happens behind the closed doors of peer review. It is like a very mercurial thing. Like you don't really see it until you're a PhD student, you get your first peer review back and then you're like, holy shit. And your PI is like, it's okay. They all are like this. So yeah, I think more visibility would be great. And I think it's an interesting example of like rational discourse that could be very good training data for LLMs that we don't have right now.
Yeah, agree.
Awesome. We'll go one more question, and then I've been told the food is here, so do not hate me. Thank you.
Quick question then. There's an axis in research which is, I think, underexplored, which is there are a lot of papers that are correct, but they're not interesting. And there are some papers that are interesting, but they're incorrect. Can you do anything about that? Because that's a very important direction not to lose.
Yes, actually, this is something that we have worked a little bit on. We just hired somebody, Connor is his name. He did his PhD on Bayesian design of experiments. And there is like a nice like formulation for what you're talking about. And like you can actually mathematically define, okay, how difficult is the experiment? How surprising is the result? And how, I don't know, like how much it contrasts the worldview. And then, oh God, there's another number in there. Oh, and it's like how likely you think that it will be successful or not. And you can try to frame this question of like, we only want things that really change our worldview, only things that like are actionable with the experiments that we have available to us. And we only want to do things that we think are, maybe likely to succeed experimentally. So yeah, I think you can try to frame that and look into it. As far as like, I don't know, user engagement on papers, maybe you could put the papers into, what is it called? Notebook LM? Like, have you guys seen this thing that makes podcasts out of papers? Yeah, I think it works.
Yeah, I think the entertainment part is probably what I think is interesting. And making it multimodal, making it more interesting, making sort of find ways to actually just talk about or get the insights out of the paper, that could be interesting. But I think it is definitely something to explore a lot more on. And yeah, we'll try.